All right, particle motion. Particle motion puts so much stuff in one spot. Um, it mixes derivatives, it mixes integrals, it mixes real world application stuff. So there's just a lot that you have to keep straight when you do a particle motion question. The good news is it is mostly just doing derivatives and net change theorem ideas. So something you need to remember, if so, let's just say position is called x of t, velocity is v of t, and acceleration is a of t. Then v of t, the velocity function, is the derivative of position. Acceleration is the derivative of velocity, which is this means it's the second derivative of position. To go from velocity to acceleration, you do an integral. To go from position to velocity, you do an integral. Movement down or left, depending on context, is just when velocity is negative. So we get direction from velocity. Speeding up is when velocity and acceleration match sign. Slowing down is when they mismatch. Particles change direction. Remember, we get direction from velocity when velocity changes sign. So we're going to do that one of two ways. If we have a graphing calculator, we're going to graph velocity and see where it changes sign, see where it crosses the x-axis. If you have no graphing calculator, you're going to find the zeros of velocity and make a number line. Total distance traveled is the integral of the absolute value of velocity. And if you have a calculator, or they're just asking for an expression for the total distance traveled, that is exactly what you'll do. Only when you have to do it by hand are you going to find the zeros of velocity and break up the integral at those zeros. Okay, let's just do it. More often than not, you're given a question that only has one particle, but there are rare instances where they give you information about two different particles, in which case just be very careful about which particle you're talking about. All right, for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine of t squared over 2. The particle is at position x equals 2 at time t equals 4. Okay, so this one is a calculator question. It wants to know at time t equals 4, is the particle speeding up or slowing down? So speeding up and slowing down, that means we need to know the velocity and the acceleration at t equals 4. So let's find v of 4. We get v of 4 just by plugging 4 into the expression, and when you do that, you end up getting 2.98 and 2.978716. You also need to find acceleration, which is the derivative. Remember, it's the calculator section. The calculator will do the derivative for you. V prime of 4 then is negative 1.164. So based on that, velocity and acceleration mismatch. So what we're going to say is that it's slowing down. It does not say explain why. You need to explain why anyway. You can't just pick one. It's 50-50. They're not going to give you credit for picking a 50-50 answer. Slowing down because v of 4 and a of 4 have different signs. So yeah, I've said this before in class. It does not say explain it, but it's a 50-50 shot. They're not going to give you credit for just randomly guessing. Okay, so there's that one. Let's look at the next one. Part B, find all times t in the interval 0 to 3 when the particle changes direction and justify your answer. So find when the particle changes direction. That's when the velocity changes sign. So something I would write on my paper is that v of t equals 0. I need to find that time, and that's not necessarily when it changes direction, but that is when the object is at rest. It might change direction there. Again, this is the graphing calculator section. So I'm going to graph this, and I'm going to see specifically where it changes direction. That happens when t equals 2.707. So I've got the time. I need to justify my answer. Well, when you see the graph of this, you end up seeing that the velocity changes from positive to negative. So the particle changes direction. At t equals 2.707 because v of t goes from positive to negative. Oh, that's the wrong. Goes from positive to negative here. Okay, so there's our full justification. Boom. All right, next. Find the position of the particle at time t equals 0. So this is one of those things where we have to think, how do I go to position from velocity? Well, that's an integral. So I need to include the initial value, though, because this is really a net change theorem problem. This is another one of those situations where I showed you guys one way, some people liked it another way. I'm going to do the I got to go back in time idea. So what I know is at t equals 4, that the particle is at position 2. So it's 2 minus the integral, because I'm going to go back in time from 0 to 4 for v of t. Writing that on your paper gets you credit. Now I'm going to go into the calculator and get the actual answer, and I'm going to find out that it's negative 3.815. Boom. Boom. Done. Huzzah. All right. Part D. Find the total distance the particle travels from time t equals 0 to time t equals 3. So total distance traveled, that is the integral from 0 to 3 of the absolute value of v of t. This is a calculator question. You're literally going to just do that in your calculator. Just be careful that you remember to put the absolute value bars on there with your calculator. So when you do that, you get 5.301. So I want to just flip back real quick. Look how little we actually did. Right? So the particle motion questions can be some of the easiest questions. You really should take advantage of them, because we didn't really do that much, but we got a lot of points for it. So let's look at the points again. Part A, you got 2 points for your conclusion with reason. So actually showing v of 4 and v prime of 4, I know it doesn't look like you're getting credit for that, but you are, because it's a 50-50 shot. You have to show that v of 4 and the a of 4 are differently signed. So you actually have to write those numbers down on your paper, even though it's not saying explicitly that you get credit for doing that. Part B, getting t equals 2.707, and then the explanation. Now again, this is another one of those things. It doesn't say you have to say v of t equals 0, but I really would, because it's any help justifying that you know what you're talking about is good to put on your paper. And then our explanation is because it changed sign. Velocity changed sign. I want you to notice something. I've been saying this in class. There are no pronouns here, right? They're always very explicit about what they're talking about. Part C, a point for the integral, a point for remembering the initial position, and a point for the answer. Easy. And then part D, a point for the integral, a point for the answer. So you have to write down what goes in your calculator on here. Okay, that honestly wraps it up for particle motion. Yes, there are some harder questions out there, but I really think that this is pretty representative.